What's he doing in there? We have a right to know.
Hey guys, got a follow-up here to the Raspberry Pi radio project. I'm looking pretty rough. I need a haircut and a shave, so we're going to switch to Workbench. There. So as you remember from earlier videos, I built a Raspberry Pi radio for my elderly mother. All it does is fires up and tunes in one station, WSM 650. We live here in Middle Tennessee, and she likes that station. She likes to listen to it at night to help her sleep or get back to sleep. And so that's all this does. This is running MPD and MPC, or is MCD, MDC, I forget, software on the RasPi. And it's got it set to all it does is once it fires up, it pulls the live stream off the WSM 650 website and starts playing. That's all it does. And so I'm using a speaker from we got these came for the G4 Cube. I had these two speakers with it. I think they also came with another model of Mac, but I'm just using one of these because, like I said, this is replacing an AM radio. That's 650 as an AM station. She doesn't care about sound quality. She just likes listening to it to help her sleep or get back to sleep. So one speaker is fine for this project, and this with this one speaker and this cheap little Dayton digital amplifier in here is as far as music, stereo music that you and I might listen to, doesn't sound that great. But compared to the single speaker AM radio that it's replacing, it sounds 10 times better. So this is fine. So no comments on, man, that's going to sound like crap. It sounds 10 times better than what it's replacing, and it's better than what she wants. So give me a break. So here's the speaker for it. Put that over out of the way. The Raspberry Pi and the amplifier and the trinket and the relay and the power supply, well, one of the power supplies, the 5-volt buck converter is in here, and then there'll be a 12-volt wall wart powering all of it. This will sit down on the bottom of the nightstand. The speaker and this control box is all that'll sit up on the top of the nightstand. And this is just a little project box that I put some rubber feet on the bottom of, ribbon cable running out of, and 3 momentary push button switches. That's all that's in there. And the deal is there's a lot of shutdown buttons. There's a lot of videos on YouTube for shutdown buttons, and most of them, all they do is send the halt command to the Raspberry Pi and tells the Pi to shut down. But the Pi still has power, because you know yourself, after you've sent the console command for the Pi to shut down, it stops all functions, but there's still power applied to it. I didn't want that. I wanted to go one further and remove power from it, because it's going to spend most of the time, 22, 23 hours a day, every day, off. So I didn't want the Raspberry Pi to have power applied, and I also didn't want the audio amplifier to have power applied. So I decided to do it this way and go one step further beyond what most of the shutdown buttons for Pis are on the internet or on YouTube. So with this one, you just hit the green button, and the Adafruit trinket in here monitors the green button. When it's pressed, it enables the 2 relays to send 5 volts to the Pi and 12 volts to the audio amplifier. It does that for 60 seconds. Why it shows 60 seconds is you have to give the Pi time to boot up and then let the Pi take over, keeping the relays enabled, so that the green button will time out after 60 seconds. But after about 30 seconds, the Pi has booted, and I'm taking a signal from it to keep the relays active. That way, when we use the red button to send the halt command to the Pi, after it shuts down, that 3.3 volt goes away from its GPIO pin, and it then disables the relays, and that cuts power to the Pi and to the audio amplifier. So the only thing in here that always has power is the Adafruit trinket board, which monitors the buttons and handles the relays, and the relay board itself. So I think when it's just running those two, I believe last I checked it was around 50 milliamps that it's pulling, as opposed to leaving the Pi on, just not running. That was like 120 milliamps or so. So that's what I did here. I'm going to have another video where I show you the internals with the Pi and everything attached, the final internals of this. But I'm not ready to show you that yet now because I haven't finalized everything and it's pretty ugly in there. So for now, this video is going to focus on an overview of this, which I just did, and the code, the Arduino code, for monitoring the trinket. And so let's switch over to this. And here's the Arduino code. And like I said, this just runs on the Adafruit trinket. And all it does is it watches the green button to see if that's been pressed, and it watches GPIO pin 25 from the Pi to see if the Pi has been booted. Either of those things, the green button being pressed or 3.3 volts coming from the GPIO 25 on the Raspberry Pi, either of those inputs will enable the relays and send power there. And so here's the setup. The trinket just has 0, 1, and 2 digital inputs, and then 3 and 4, which are a mix of digital and analog. And so the green button pin is going to digital input 2 on the trinket, the power on signal from the green push button. A relay pin and B relay pin on digital outputs 0 and 1. A relay is for the 5 volt relay to send power just to the Raspberry Pi, and the B relay channel sends 12 volts to the amplifier. An interval that I've named Pi value, this is the value coming from the GPIO 25, we have it set to 0. The unsigned long interval, this is code here I wasn't aware of, and I'm still not that up on, but like a lot of you, I know how to copy someone else's code, tweak it to what I want to do, and this worked perfectly for giving me a timed input off of pressing the green button once. And so this unsigned long interval is set to 60 milliseconds, which you can see here in my notes equals 60 seconds. And so this is the code for that unsigned long start time by last press. These three here are dealing with when you press the green button, enable the relays for 60 seconds. That's what that deals with. The setup here, pin mode, set the button pin to an input and the 2 relay pins as outputs. That's normal stuff there. And down to void loop. Remember up here I named this interval Pi value, and that's what we're watching for. That's what I've named this signal coming from the Raspberry Pi. The Raspberry Pi, when it boots up, I have a Python script that does 3 things for the GPIO pins. Number 1, it sets GPIO pin 25 to high. That's all it does. It sets it as an output and sets it high. I'll show you the Python code later in another video. And that's just to send the signal over to the trinket that tells it to keep the relays active. The Python script also tells you it sets GPIO pin 23 and GPIO pin 24 as inputs, and they're watching for signal from the 3 buttons. It's actually watching for input from the red button and the yellow button. The red button sends the pseudo shutdown TAC H now signal, which tells it do a graceful shutdown and do it now. That's the red button. And the yellow button is basically a 1 hour sleep timer. Mom sometimes she had a 1 hour sleep timer on her old AM radio, and she said she used that a lot, so I was able to do that. That simply, I have the Python script watching GPIO pin 24, which is connected to the yellow button. Whenever that goes high or low, I forget how I have it set up. That then runs sends the command sudo shutdown TAC H for halt plus 60. And the plus 60 is, instead of sudo shutdown H now, what shuts down now, if you change now to plus 60, it will tell it to shut down or to send that shutdown command in 60 minutes. And you can change it. If you want it to be 5 minutes, you just put plus 5. If you want it to be 20 minutes, put it plus 20. If you want it to be an hour, put plus 60. It's going to be for minutes. So that's all that does on the Pi. And so, like I said, the Pi sends out a signal once the Pi is booted and it runs that script. It sets GPIO pin 25 to high, sending 3.3 volts out. All this trinket does now is it watches for the Pi value, which is coming in on analog pin 2 on the trinket, and it simply watches that and it waits for and it watches for the value. The value, I did a test on it using an Uno so I could watch the serial monitor, and I found that whenever 3.3 volts was applied from the Pi, that I was getting around 620 was the raw value I was getting in on the analog read pin. And so I set if Pi value, the voltage from the Pi is greater than 450. I set 450 because I figured that gives me some wiggle room between 620 and down around 100, which is where the pin sits when there's when GPIO 25 is not gone high, because there's a little noise in the line. I set it to 450. I could probably set it to 350 or 500 or even 600, but 450 works just fine. So this is a signal coming from the Pi. If it sees this voltage on the analog read pin 2 from the Pi, that tells it that the Pi is booted, and so it tells A relay pin and B relay pin, sends them both high. In other words, it keeps them high. And so it looks for that first. If that's not true, then it goes to the else part of the function here, which says, watch for your button presses. Has the green button been pressed? And it does a digital read on the button pin. If it's pressed, it says, does the press not equal the last press, which it won't if it hasn't been pressed before, and the time hasn't run out. It sets both relays to high. Then it sets your start time equal to millis, which is the timing on the Arduino. And then it comes down and watches for the last press equals press. And you're doing a digital read on the A relay pin. And then it just says if the millis time minus the start time is greater than or equal to the interval that we set up here, unsigned long interval, 60,000 milliseconds, which equals 60 seconds. If millis minus start time is greater than or equal to the interval, set the relays off, meaning the 60 seconds has expired, turn the relays off. But only if you don't have the 3.3 volt signal from the Raspberry Pi. So as a recap, the trinket simply watches the button pin and watches analog read pin 2, and it's looking for one of two signals. It's looking for a button press on the green pin, and if it sees that, it enables the relays for 60 seconds, and after which time it'll time out, and that enable signal for the relays goes away. But it's also first looking for the GPIO pin 25 coming in on the analog read pin 2, and if it's over 450, which it will be if the Pi is sending 3.3 volts, it'll actually be around 620 on mine. If it's over 450, it writes both the relays high. And as long as it's over 450, these relays will stay high, which means as long as the Pi is on, the relays are going to stay on. Once the Pi shuts down, then it'll turn it off. And that's that. I'll post a link to this code in the comments. Next time we'll get into the Python script, which is just pretty straightforward. At the same time, I'll do a video showing you the Python script and showing the internals of the final assembly of the Pi radio, and I'll let you see it or see and hear it working. And I may add some LEDs to the buttons so Mom can see them at night. And because, hey, LEDs, man, you gotta have some LEDs on your project. Thanks, guys.